Hello, I'm an old guy and I do maths. And today we're going to look at differentiation and the process involved in doing it. So this is a video about the very beginning of your work with differentiation. Um, by this time, if you're doing this in high school, I guess, or maybe you're seeing it for the first time at university for some reason, um, you may have been introduced to differentiation by first principles, which, although it's extremely clever and pleasing to the mind, can be quite confusing. And there is a shorter and easier process, and what we're going to do is we're going to look at that today. This is really where you start, and it's very simple. Let's say that you have an expression ax to the power of n. So that is your function of x. The differential of that, which you could write as dy dx, which might be the notation that you're used to, is this. The a is multiplied by the n, and we subtract 1 from the n. So let's take an example. Something where there's no mistaking what's going on. So 3x to the power of 4. That's a, that's x, that's n. Let's go to work. So we multiply this by 4. 4 threes are 12. And we subtract 1 from 4, which is 3. And that is the differential of that. Okay, now you can do this over and over and over again. So y equals x to the 5 plus 3 over 4 x to the 3 plus, what will we say, x to the 2 plus 3x plus 2. Now, there's an important step in here. We're only interested, when we differentiate, we're only interested in these effectively, because what we can do is we can write this as 2x to the 0 and this as x to the 1. Okay, now 2x to the 0 is simply 1. Okay, and we'll deal with this in a slightly separate explanation, but just watch what I do. So dy dx is going to equal 5x to the 4. 3 threes are 9 over 4, x to the 2, subtract 1 from that, plus 2x to the power of 1. 1 times 3 is 1. So that's plus 3, and we subtract 1 from the x, and we get x to the power of 0. So that's just 1. So that will effectively disappear. Now, this is the entire differential. What do we do? What do we do about this? Well, we're only interested in the forms of x. So what do we do? Well, if you attempt to differentiate this, this is what you'll get. So 2x to the 0. Now, what's the process? Well, the process is that we multiply this by this. So we wind up with 0 times 2, and we can subtract 1, and we will get 0. There is nothing there. So the differential of this entire expression here, I'd go through this slowly. We had x to the 5, x to the 3, x to the 2, x to the 1, and x to the 0. We subtracted 1 from this. We multiplied this by the coefficient of x here, which was 1. So we got 5x to the 4. We multiplied this by this and got 9 over 4. And we can leave that in that form, that's fine. Subtracted 1 from this and got 2. This had a coefficient of 1, so it's 2 times 1, which gives us 2. Subtract 1 from that, which gives us 1. 1 times 3 is 3. X to the power of 1 is x, but x to the power of 1 minus 1 is x to the power of 0, and x to the power of 0 equals 1. So it's effectively 3 times 1, so we just leave that as 3. And this, because of this, winds up as 0. So a tidy form of this is dy dx equals 5x to the power of 4 plus 9 over 4x to the power of 2 plus x to the power of 1, we can just leave that as x, plus 3. So this is the differential of this. But let's just go back and restate the basic idea. You start off with an expression like this. It's got a coefficient. That coefficient might be 1, so you might not see it. It's got a coefficient, it's got a pronumeral, and it's got a power, an index. And what you do is you multiply that coefficient by the index, and you subtract 1 from the index. That is all you do. It is very, very simple and straightforward. And here's a practical, simple example. 3 times 4 is 12. 4 minus 1 is 3. And what I've done here, which you can choose to look at or ignore, that's your business, is I've strung a series of terms together and I've found their differential. Nothing could be simpler. In fact, very little could be more simple. This is a very straightforward process. Now, I will be putting up other examples of differentiation. So there'll be surd and index form and a whole pile of others. And I'll make it my business to put up just some expressions like this and work through the differential. But this is the place to start. Just remember, if you're starting out, this stuff here. I hope that's a good start for you in calculus. It's a really wonderful area of maths. Thank you very much for watching. See you next time.